Hello, today I'm going to go over Sea Level Rise, Thwaites Glacier Lecture. So we're looking at Antarctica here, and we know that climate change is warming the atmosphere and it's warming the oceans. This has already been proven. So what we're worried about is some of this ice that's on land melting into the oceans and raising sea levels. And the area we're going to focus on is Western Antarctica here. That's this unshaded region. Antarctica is covered in a thick layer of ice. As the planet warms because of climate change, ice in Western Antarctica will continue to melt into the ocean and significantly raise sea levels. So this ice will melt before this ice. Now we're going to look at a section here. So it's right about this area that we're looking at here. And there's this huge glacier. And when I mean huge, it's about the size of Florida. So it's massive and very thick too. So this is the Thwaites Glacier. It is melting the fastest. It's the fastest part of melting in Western Antarctica. So we're going to highlight this. Ice from Western Antarctica is already melting, and the largest amount is coming from Thwaites Glacier. As it melts, it will expose more of Western Antarctica to the warm waters of the Southern Ocean. So the waters all around the world are warming up. This is the Southern Ocean, or the Arctic Ocean, that surrounds Antarctica. And it's touching part of Thwaites Glacier, both these spots. Okay, so now we have Antarctica, but we have a slice through Antarctica. So this is like a cross section. And we see two different areas, Western Antarctica over on this side, Eastern Antarctica over here. East and West Antarctica have different elevations. We can see that this side here is different than this side here. Higher mountains, higher landforms over here compared to Western. The high elevation of Eastern Antarctica keeps it stable and melting is slow. Because most of it is above the surface, the ocean surface, this is all melting very slowly because it's not being exposed to that warming ocean water. Western Australia, or Antarctica, is more exposed to warming seawater and is melting much faster. So what's going to happen, or what is happening, is this area is starting to melt, and a lot of this is under the level of the ocean, the sea level. So as water melts this area, it'll pour into here and melt all this very rapidly. This will cause a positive feedback loop. The point where the glacier meets the bedrock is called the grounding line. That's this in the red circle here. That point is the grounding line. Ice meets bedrock. Increased temperatures cause the grounding line to move backwards, and in the case of the Thwaites Glacier, move deeper. So this water here is just going to keep melting and carving out a tunnel underneath. It'll get deeper as it goes down the slope of the bedrock, and this whole chunk of ice will start melting and breaking off quicker and quicker and quicker. Thwaites Glacier grounding line has retreated 14 kilometers in the last 30 years. So what that means is this point has gone backwards by 14 kilometers over the last 30 years. Using satellite imagery, we can see massive chunks. That's all this. Massive chunks of glacier breaking off and floating away. As more of the glacier is exposed to ocean water, it melts faster and exposes the rest of Western Antarctica to warmer conditions. If all of that ice melts, southern Florida will be completely submerged. So here's Miami area. All of this area would be underwater, and still much of the coast of Florida would also be submerged under the ocean. And we're just talking about Western Antarctica, not what would happen if all the ice in Eastern Antarctica melted. That would be later on. Okay, I hope this helps. Thank you very much.